Hello everyone, welcome back to the channel. Let's define the list or the needed entities for our projects. Under the entity folder, create a new file. It's going to be basically a structure. Let's start, for example, with the application settings entity. First of all, I'm going to import grdb. I'm going to use here the fetchable record and persistable record. Allow us to retrieve, and this basically to save data to database. And since we are going to identify this application settings with its dedicated ID, it has to use identifiable. For the fields, we have public variable ID of type integer 64 and is dark mode as well as latest route. Now we have to add the initializer. Let's define the coding keys. By defining the coding keys like this, it's going to be saved under this particular field. It's going to be saved like this. And the latest route is going to be saved like this representation. Next, we need to store for the ID the latest inserted ID from the application settings table by doing mutating public function did insert ID equal the inserted and raw ID. Cache or sync in memory the latest inserted ID of this particular application settings table. And let's specify here the columns from the coding keys. For the first column, it has to be static let ID equal the column and the name of the column from the coding keys ID. Likewise for as dark theme and latest route. And let's not forget to add the public accessor or visibility modifier. And I would like to add here the table name from the constant file that we have defined under the miscellaneous folder. And this is basically how to define the entities. I'm going to go through the others briefly in order to save some time. And we have added here for this particular entity, image entity, we have added equatable for testing purposes and mutable persistable record. And for the rest, it's the same thing that we have defined previously as the app settings entity. We have here the ID, title, category, price, quantity, and description. And we have to specify, basically, which is very important, the images or the media. And for the media, it is a relationship by doing public and static let. This is basically under from the documentation of grdb to define the relationship. Let's call this images, and the relationship between product and media is one-to-many. Therefore, it has many. Now we have to specify the entity, which is image entity. Now for the key, it is images. And we have to specify here the foreign key. Under the image entity, we have the field model ID. This is the foreign key under image table or images table. And under product table or products table, we have the primary key, which is ID. Next, we need to store those the results of this images under variable to get the list of the related images using the relationship. Query interface query, product entity, and images. The rest is pretty straightforward. We're going to define the database table and auto override the value database table, as well as provide the coding value and to synchronize the latest inserted ID. That's all we have for the product entity. Let's move to the wishlist item entity. For the fields, we have the ID, product ID, and user ID. And of course, we have to define the relationship between a wishlist item and the product. I'm going to copy this, paste it here, and we have to change some stuff. In one hand, we have to provide here the related product entity. On the other hand, we have to provide the relationship. Here, it has to be the relationship that's going to be defined under our relation folder. Let's call it products images or products with images. For the foreign key, basically, we have to provide here the ID under the product entity table. And for the other one, which is product ID, that has been defined under wishlists items table, if you will. Now we need to store it somewhere. Let's call it here product. And for this one, it's not has many, it should be has one, because the relationship between wishlist item entity and the product entity is one-to-one relationship. Now for the request, it's pretty simple. This has to be of type product entity. And for this one, wishlist item entity dot self. And we have to call this one product. So that's pretty much it for the wishlist item entity. And for the rest, it's going to be pretty self-explanatory. We're going to define the colons and to synchronize between the latest inserted ID and assign it to ID and the coding keys. The last entity, which is the user entity, let's provide the ID, name, email, and the email verified at, as well as the needed relationships. Now for the relationship here between the user and the wishlist, a user can have one or many wishlist items. Therefore, it has many relationships. With the same manner, we have to provide the foreign keys, the user ID that's been defined in user entity, as well as the ID of the user in user table. And where to store the query interface request, let's call it wishlist. And we have to override database table name. And this is not mandatory, but I would like to do it this way, as well as the colons and to synchronize the latest or to get the latest inserted ID and assign it to ID. And of course, we have to provide the initializer. That's pretty much it for the entities of our application. Now let's go ahead and define the relationship. It's the same thing basically that we have done under, not the same thing though, but almost the same thing or the same principle of Room database. The first relationship that we need, because it's a 3 deep level relationship, therefore we need to do the same thing as Room database. Relationship between products with images, then wishlist with products and images, and we're going to finally define the user with wishlist and products and images. It's going to be a public structure. Let's import first of all here the GRDB. It uses a fetchable record. Of course, we have to do here decodable. Now for the first thing that we have to define here is the parent entity. Now the images, because it's one too many, basically it is a list of image entity. As simple as this. We have to define the wish list with products and images. Now we need to define the parent entity, which is wishlist. And the relationship between wishlist item and the product is 1-to-1. There is a nested relationship here, therefore going to call it product with images. This has to be nullable. We don't know for sure if there is a product with images or not. And this has to match the relationship that we have defined here under wishlist item entity. It has to match this one. So I'm going to copy this just to make sure and paste it here in order to avoid making typos. Now we can define the top level relationship, which is user with wish lists and products and images. The parent one or the owner is going to be the user of type user entity. And the relationship here, it's wish list. It is basically a list of wish lists with products and images. And this is how to define basically the relationship in GRDB package or GRDB library. Now let's go ahead to define the list of models. Here, nothing substantial. We're going to define models as structures basically. And the domain creates a new package or a new folder. Let's call it model. Let's start with the most easiest one, which is app settings. It is very simple. It's dark theme and latest route. With the same manner, we're going to define the rest. This is the image model. Now we can define the products preview. And for the products preview, I have added equatable for testing purposes, as well as identifiable, because we're going to list in the products fragment in a grade layout available products. Now for the product, nothing substantial for the product. We have the list of images. I would like to add here a computed property in stock that we have defined previously under Kotlin application. Quantity should be greater than 0. And another one for the original images, we're going to access only the original images from the media. It will be just media and compact map inline manner by doing, let's provide here the URL from the string value. And to access the first parameter, instead of declaring here the parameter, we can access the first parameter by doing $ and 0 and point original. That's pretty much it for the product model. For the wishlist item, nothing substantial. We have to provide here the ID and product detail. Now for the last one, which is the user model, I would like to add here a computed property or a function in wishlist to check if this particular product is in wishlist or not. We have to return wishlist and we have to call the contain first parameter. We have to do product ID equal product ID from the parameter. If you do remember, we need to handle the pagination. Therefore, I'm going to create here another model. I'm going to call it pagination response. Under model, create a new folder, call it pagination, just to keep our models organized. The generic of type T, it has to be codable. You can do here decodable and encodable, but I think codable groups codable and encodable both. Data, which is basically an array. And we have the other fields, first link, last link. Let's provide here the constructor. I would like to add the empty useful or static function. Likewise for search pagination response. And that's pretty much it. We need to come back to the Pocket Goods database manager, and we have to implement those useful or util functions under Pocket Goods database manager. That's going to allow us to stream the user as well as stream application settings. And we need another function basically to get the cached user. I would like to keep things centralized here under Pocket Goods manager and not to do it. It's just a personal preference, to be honest, but you can do it actually in the util package or to add it as an extension function. For the first one, this function is going to return any publisher. And to use any publisher, we need to import combine. Any publisher plays the role of flow, basically, under Kotlin. So there is a resemblance here. And we have to provide two parameters or types parameters. The first parameter, which is a user, it could be null, not necessarily is saved in the database. And the other type is never. The whole thing will return a publisher, all right? Luckily for us, GRDB is doing that under the hood, and it provides for us a very good way to observe our changes when it comes to the entities. How to do so? We're going to use value observation, and we can track basically the needed entity. And we need to do some kind of query, if you will, by doing try user entity. And we need to include with this query images and products and wishlist. And we have to precise here the user entity. And we need to access or to include with this fetch operation or retrieve operation the wishlist. And this particular one, because we have actually a 3D relationship, we need to include with it another information. Why it's optional? It's a nullable basically. That's why we do optional here. Now what we have to include here is wishlist item entity. And we have the product because we need to access the product as well. And from the product, again, we need to include another thing. It should be not optional this time, and the product entity and images. This is the query. We can filter by the user ID, call here as a request to perform a database query. And the type here, we need to provide the needed or the relationship that we have defined, which is user with wishlist and product and images dot self. And we need only one record. Therefore, we have to use fetch one. And we have to pass here the database. Now under tracking or underneath tracking, we're gonna call here publisher because this one is going to return, it's gonna give us a publisher. Let's pass here the writer as an argument, and we have to receive this on the dispatcher queue main or the main dispatcher. Under publishers, we can run mappers here to the user model. Basically, we're going to map user with wishlists and products and images to which wishlist model. Now let's come back to the package mapper and let's add the first mapper. Basically, mappers here are extension functions on app settings. It will return basically app setting model. Another extension function on app setting model if we want to save the data to the database. Therefore, I have to convert from the model to the entity. As simple as this. Let's create another file for image mapper. The first extension function from it's going to be on image entity, and we have to convert from image entity to image model. The second one we have to convert, it's going to be an extension function from image model to image entity. The third extension function, it's going to be on image DTO. We have to convert from image DTO to image entity. We need to convert from the image DTO to image model. And this is the image mapper. Now let's create the other one, which is for the pagination response mapper. I'm going to call it pagination mapper. It has to return an instance of type pagination response, and we have to pass here basically the generic type. In order to do so, what we have to do, first of all, let's add here the generic type. Let's call it model. And because the pagination response has the data field and the data is an array of type T or of type DTO, we need to add a mapper as a callback function that's going to map from the DTO to the model. I'm gonna call it here 2, which stands for the mapper function or the callback function that has to be passed as an escaping function. Normally, a closure must finish running before the function ends. If the closure needs to run later, like for example, after a delay or when data comes back from the internet, for example, this is basically our case, we mark it with escaping. You can think of escaping as this closure will escape the function and be used later. For the parameter of this escaping function or this mapper that we have to pass as an argument, it should take a DTO type T and it should give us a model. Now it has to return pagination response and we have to fill in the blanks. For the data, it should be data map and we have to pass as an argument to closure callback function. And for the rest, it's going to be very easy. I'm going to delete this for now. And if we do need to add the keyword escaping function, we can do it if needed. Likewise, for the extension function on search pagination response DTO. And that's all for the pagination mapper. Let's focus on the products mapper. The first extension function should be on the products with images, from the products with images to the products model. The second one should be on the products model, the case where we're going to save the data. The third one on products DTO, from product DTO to the products entity. For the preview DTO, we need to convert from products preview DTO to the preview model. And the last one from the products DTO to the products model. The whole thing can be actually available under the GitHub repository if you're not interested in this particular section. The most important thing here is to know how to define extension functions. Now for the wishlist mapper, we need to convert from the wishlist item entity to the wishlist item model. The next one on wishlist item. Basically, we have to convert from wishlist item to the wishlist item entity. Under the same extension on wishlist item, we need to convert from the wishlist item model to the wishlist item DTO. Now we need to convert from wishlist item DTO to wishlist item model. And another one from the wishlist item DTO to wishlist item entity. The last mapper that we have to create here is the user mapper. Now we need to convert the entire relationship, which is user with wishlist and product and images, to the user model. Next, we need to convert from user DTO to user entity. However, for the email verified as, we need to convert from the string to date. Let's come back to the miscellaneous folder. I'm gonna create here another folder. I'm gonna call it date, a new file. I'm gonna call it date extension. I'm going to create here an extension function on string to the date, and it could be nullable. We're going to use the formatter and to format the date to the needed format. Formatter and date, all right? And we have to pass the format. Add here a parameter format. It could be nullable, if you will, and the default format is set like this. Let's create here, first of all, the format or formatter. It will be date formatter, and we have to specify here the format by doing formatter and date format equal format. Now let's use this extension function in the mapper. You have to use the null safety operator and you have to use toDate. As simple as this. Now we should map from the user DTO to user model. I have thought about this idea for a while, and since Swift does not have the copy function, which is a very huge debate under Stack Overflow, how to create in a generic manner the copy function that we have used time and time again in the Kotlin programming language. It's not defined by default for a reason. If you want to do it under Swift in a generic manner, it's not that easy, to be honest. Therefore, I'm going to create a dedicated copy function only for this user DTO. Perhaps we're going to use this under testing or the repository or the view model. We never know. We have to provide the necessary parameters, and it has to give us the user DTO. And it has to return the user DTO. Now, the trick here to copy this particular instance is to do, if it's provided, if the ID is provided, we're going to assign ID to the arguments. If it's not null, we're going to take it from the self and from the DTO itself, all right? Likewise for the rest of the fields. This is basically the simple implementation for copy method, but I tried to actually come up with a solution to do it in a generic manner, but it did not work in all cases. So I prefer to do it this way. That's pretty much it for the entire mappers. And we have an unfinished business under the Pocket Goods Database Manager. Here we can safely convert from the user wishlist or user with wishlists and products and images to the user model by doing $ and 0 to user. I have to use basically the extension function on user with wishlists and products and images. And if we have any error, what we have to do here is we're going to emit a null value. At the end, we're going to erase to any publisher. Basically, as written here, wraps this publisher with a type eraser. As you can see here, we have an error. Type user wishlist images does not conform to sendable. The only way to overcome this issue is to use or to confirm to the protocol sendable. Let's come back to the user wishlist and products and images. We have to add here as a first sendable. So briefly, what is sendable? It's basically a protocol. In other words, it is an interface that marks a certain type as safe to be sent across threads or tasks. This is defined under Swift's concurrency system. Think of it as a thread-safe stamp of approval, all right? By default, we have integers and strings are thread-safe to be sent across multiple threads and tasks, but we have here the user and the wishlist are not marked as sendable. Let's come back to user entity, and we have to add here this again as sendable. We're going to do this according to the needed declaration. Let's come back to the product or user with wishlist. It should be gone. Now we have to do the same thing under wishlist with products and images, but we have to mark this one as sendable as well. And for the products with images, sendable as well. And we have to provide here sendable or to add sendable. All right, after all the entities has conformed to the protocol sendable, the error is gone. And basically we have the stream user ready to go. With the same manner, we're going to stream the application settings in order to have the real updates of the latest saved route or visited route, as well as whether the application should be under light mode or dark theme. Forgot actually to add here the keyword throws, because the whole thing can throw an exception. And let's add here throws, application settings model, and never. It will return value observation, tracking. Let's add here database. Basically, there is no needed relationship. We're not going to include anything here. App settings entity. We have to filter by ID 0, which is optional, if you will, as request of. And the request here just gonna be the application entity fetch only one record. Publisher in writer on the dispatch queue main. We have to map the result to the model by doing $ 0 and to app settings model. If there is an error, we're going to emit null result by doing just and null. At the end, we're going to erase to any publisher. And we have the same error here. We have to add sendable to the app settings entity. One simple function that we have to add here, which is to get the cached user data. I would like to add this here instead of the repository implementation, because here, as I said before, we're going to centralize everything in this particular class. It's going to be an async function, throws, it will return, try, and await. Going to use reader in order to read data and read. And we have to include the same thing that we have done previously by doing try and the user entity, including, first of all, we have to include the wishlist by doing user entity and wishlist. We have to include again the wishlist item entity, which is optional. And we have to add here another including for the images by doing products entity and images. As I said before, it's going to be only one snapshot. Therefore, going to use here limit 1 as request user with wishlist and products and images and self and fetch 1. And we have to cast it to user. We need to make our models thread safe. Going to add sendable to all the needed models. And that's all we have for database section of our application. We have done basically an extensive implementation under the core application, and we are not done yet, to be honest. We still have more things to do, especially when it comes to API service, as well as the crypto, I think that we are going to stop here. For the next video, we're going to focus on defining basically the dependency injection mechanism for our application. I hope you liked the video. See you in the next one, and happy coding.